So first, I will introduce me in a few words, and then I will speak about Carbon Water's innovation and products. So myself, I have a technical and management background. So I've studied in France and the US, mostly in biotech and biochemistry. So I've worked also in a consulting company in France, focusing also on innovation for financing and managing innovation. And I created Carbon Waters. Now it's almost 7 years ago. So it's based on a new innovation. It's a process innovation. It's not a product innovation at the beginning. That is protected by 3 patents. So initial 3 patents, and we have 4 more patents from Carbon Waters. And the company is based in Pessac, so it's close to Bordeaux in France, so in the southwest,
Yes,
very famous for the wine.
of course.
We are now 20 people, so mostly physical chemists and material scientists, and also business developers. And what's different about Carbon Waters versus potential others nanomaterials companies is that so we are our innovation is based on a new process, and this process allows to manipulate carbon-based nanomaterials, and especially graphene, in a liquid form, in a very stable format, and also allowing very thin nanomaterials stabilized in the product of our customers. So most of the products are polymers. So we focus on thermosets and thermoplastics with different markets that we target. The most important one is composites, composites for aeronautics, building, automotive, and also wind turbines. But also polymers that are used in different kinds of industrial sectors. And what brings our nanomaterials in these polymers? So thanks to their very good stability and very good dispersibility in polymers, we propose to increase the mechanical resistance of polymers and composites, so our customers can use less polymers but also less composites to achieve the same mechanical resistance, meaning that they save in terms of materials, energy, and then in money. So the impact of the innovation in terms of margin for our customers is about 10 to 20%,
Wow.
depending of the industrial sectors. So now we are on the phase to qualify the products with very big chemical companies in Europe, of course, first, but also with companies based in the US and in Asia. So mostly polymer companies and also composite companies.
Understood. And that's a very good refresher on what carbon water is. I mean, what are the unique things about carbon water? As you talked about, it's the process
Mm.
as compared to the product. And maybe it would help if you can explain what's so different about the process. Of course, there are patents on it, people can read about it. But I have been hearing about graphene since like the past 15, 20 years, that it's a
Yeah.
super material, very good conductivity, better than everything in terms of enhancing the performance or the properties of
Mm.
other materials. I mean, it's such a good source. So is it the stability part which was lacking, which Carbon Waters has brought out through its unique process? What is it that is changing in the current industrial process because of Carbon Waters, of course?
So you're absolutely right. So graphene was identified more than 20 years ago now. It has amazing properties. So it's very bizarre that you cannot find graphene everywhere in the economy and in the products. Uh, there are 2 things that are, let's say, decreasing the speed of adopting graphene by the industry. The first one is that most of the companies, they adopt a tech push approach, saying that the technology is good, so the material is good, so it's going to be sold. The way we work at Carbon Waters is that first we settled an engineering office. So we discussed with the polymer manufacturers, the composite manufacturers. We understood their process. We understood also their economical and technical objectives. So we designed the product according to that. So this is the first thing. The second thing is that it's absolutely right. So we are a process company. And what we saw is that stability is key to obtain the best properties for graphene into the products of the customers. So we've worked a lot on balancing between having the best stability but also the best quality of graphene, meaning the thinnest graphene possible, stable in liquid form, So we have developed this unique process, and now we are very happy to see that it works. Our customers give very interesting feedbacks, and they are now going to order big quantities of graphene as an additive for polymers from carbon waters.
Wow, that's great to hear. And I think so. What in general is the challenge? So, of course, you also mentioned that graphene is being provided in the liquid form for coating purposes on composites in aerospace and aeronautics application. So, I mean, is it the solvency because of which we have to go to the nanomaterial size so that it is applicable in terms of coating? Is that one of the things that Carbon Waters is working on or has perfected the process? Is that one of the things, or is it a different understanding?
So it's really linked to the process itself, meaning that so we produce graphene from graphite. So graphite is a superposition of carbon layers. Most of the process they break graphite into tiny pieces. They call these tiny pieces graphene, but by themselves they are not stable. So what we introduce at Carbon Waters is that we use ions that we intercalate between the carbon layers. So we begin to separate the carbon layers, and then we enhance this separation by high shear mixing and but also some sonication, but balanced sonication. So we end up the graphene to be stable thanks to the ions without any chemical modifications. This is very important because most of the companies they propose chemical modifications of graphene to stabilize it, but if you chemically modify the graphene, then you change also the properties.
Yes,
So we propose a pristine graphene that is stabilized thanks to the ions that are not covalently bind.
that makes sense. That makes sense. So I think the innovative process or the hard work that we have put in the last 7 years, 8 years is perfecting the process where no additional chemicals are added, and the graphene outcome or output is still stable and usable by the industry, right? Without changing the properties.
Yeah. Most of the work we have done is um, balancing and mastering the process, but also increasing the quantity because at the beginning we have produced only like several hundred milliliters, and we have stabilized the graphene in very few amounts. So now we are producing several thousands of liters of this dispersion directly in polymer. So it takes time also if you want to increase the quantity of nanomaterials in liquid form, you need also to master each scale up stage and be sure that you keep the same stability and the same performance.
Yes, yes. Now, when I hear you, Alban, one of the things that I imagine is this requires a lot of research. This requires a lot of hard work where the lead time before it goes into an industrial product or application is greater as compared to, say, for example, something which is like a packaging material directly applicable to industries. It is easy to produce, so on and so forth. Now, this kind of research takes time. So it's highly scientific, it's highly experimental, and I mean each result decides the next step as to how you are going to move on
Mhm.
from there. Now, that also requires a lot of time investments and money investment. Now, with respect to carbon waters, I imagine this originated as a technology transfer from a research institute, right? So how was that story? I mean, first of all, I wanted to ask you, how did you qualify that this is going to be a great product or a great application if we are able to stabilize this? I mean, what was the thought process at that point of time which made you decide
Yeah.
carbon waters is the way to go?
So the story begins at 2004 with the first patent. So patent was this first patent was designed from an academic laboratory from an institute called CNRS, and they've worked on several other patents to enhance and master the process. So it was more than 10 years of academic research before we even discussed about the potential foundation of a company. Then it took 4 years more just to think about what the company will do from these patents. And that was the beginning of the creation of Carbon Waters in 2018. So meaning 14 years after the first
Wow.
patents. So
Wow.
it's you're right. It's a lot of research. It's a lot of investment in R&D. But even though Carbon Waters was created, we had also to invest a lot to on more product development than pure academic research and development. And it took us more than 3 million additional investment to
Wow.
work on mastering the process to a pre-industrial level that we are now initiating. And we began qualify the products in 2022. So meaning 4 years more of process development after the
Wow.
creation of carbon waters. So yeah, it's a lot of money. I think it's more than 6 million that has been invested in research and development at carbon waters innovation so far. And from the initial patent, it's almost 20 years.
Wow. Which is the lifetime of a patent.
Yeah.
Yeah. But that is great to hear. I think, I mean, these are the type of startups that we are seeing less and less of nowadays. I mean, it's more short term exit strategy that a lot of people are deploying. And then there are
Yeah.
application areas where, I mean, people are working. So, I mean, it is, of course, very pleasing to see scientific research originating from academia getting transformed into industry, because, I mean, academia has that purpose that they can do theoretical research, but at the same time, industry can leverage that and then ultimately put to use. So it is great to hear about carbon waters. Now, I wanted to understand the application areas in a bit more detail, right? So, for example, you talked about coatings, whether it is for protection, whether it is for any other property enhancement. So, can you help me imagine? Is it going to be a layer on the aircrafts? Is it going to be something which coats any other industrial output? I mean, what is it if we want to imagine? I mean, what carbon waters
So
products
when
are?
when we discussed with coating manufacturers about graphene application, it was mostly for protective coatings, so meaning primers. So when you do the painting of a surface, of a metal surface, you use a lot of different layers. You have top coats that are on the surface that are more for mechanical protection, and you have primers that are really at the bottom layers. And these primers, they are the one that protects the metal from corrosion. So we have developed two types of additives for primers, for coatings. One is solvent-borne, mostly for high value applications such as aeronautics, but also marine industry. But we know also that there is a very important trend, especially for the decorative, architectural, and building paintings, to move from solvent-borne to waterborne uh, for obvious security and safety reasons. So we have worked also on a waterborne additive for coatings, and both solvent-borne additives and waterborne additives are now under qualification by coating manufacturers, and we are receiving the first orders from these coating manufacturers to add the graphene dispersions into their paint.
Wow, wow. So, Alvin, I also wanted to understand the economics of carbon waters. Now, the primers and the coatings and the protective layers that are in current use, they have been developed and have been adapted or adopted by the industry from a long time. So, of course, the economies of scale come into play and their costs might
Mm.
be down. At the same time, graphene based additives for performance enhancement will be much, much better in terms of performance. But then comes the cost factor also. So, how is the industry reacting to the cost versus the performance versus the carbon footprint
Mm.
reduction?
So for each product, we have to build a customer value proposition, meaning that we had to measure what's the effect in terms of margin, final
Hmm.
margin for our customers using our product either on its own or either replacing an existing one.
Yes.
So we have been doing this exercise for the coatings. Most of the additives that we are developing are replacing zinc-based additives that are very mature additives. So it's very difficult to compete with an existing additive that is broadly used at the coating industry. But what we have seen is that there is a synergy between our additives and the zinc-based additives, meaning that the way they are used and the way they act as protecting additives is different and acts in synergy. And we have seen by decreasing by 50% the existing additives and replacing them by the graph-up products from carbon waters, you can just not achieve the classical protecting level that you have with 100% zinc-based additive, but you go beyond that. You have a better protection. So meaning that you can also uh, um, introduce a small premium of the graphene-based additives based on the fact that it is more protective than the zinc-based additives, and you can also reduce 50% of the zinc-based additives, meaning that there is also a cost release on the final product.
Yeah.
So we have been doing, so for the polymers additives, it's a bit different because on most of them, we don't have any competing products. So everything was calculated based on the fact that if you increase the nickel resistance, you decrease the quantity of resins and fibers into the composite, so you decrease the price of the composites. And even though it's an innovative product, by integrating these innovating products into the composites, our customers can increase their raw margin significantly.
That makes sense. That makes sense because a lot of startups that I talk to, especially on the material side of things, they find it tough to integrate with the existing process. But the way you explained it, you are not replacing it, but you are rather complementing the zinc based coating material. And in the
Mm.
same process, you're reducing the original material so that more graphene can be added and more performance can be taken out of the same amount of material. And that makes sense because then there is a motivation that suddenly the cost does not rise up for the customer. Because a
Mm.
lot of times I have seen a very innovative companies not being able to be accepted by the industry because the bottom line comes into the picture. If everything is in place, production lines are stable, and you want to change something in that, you want to change the process, you want to change the composition, and at the same time cost gets affected, suppliers demands, everything gets changed, people don't want to move the bottom line
Yep,
because I mean it's a
absolutely.
set process. Yeah, I mean if it's
So
not broken they don't want to actually fix it. But and that is one of the resistances I have seen a lot of material based innovative startups face. But I think in your scenario it's a very good approach, an approach that's very well thought of, where you are phasing out rather than replacing certain existing compositions. So that makes sense.
yeah,
Uh,
you're absolutely right. It's really like we have a disruptive innovation, but we don't want to disrupt the economy. We don't
yeah,
want to disrupt the process. So everything should be the same, but just better
yeah,
with this disruptive innovation. So we have worked a lot on adapting the innovation to the existing products and to the existing process. We don't want our customers to change anything. They don't have to invest in any capex. They don't have to learn anything new. It's a plug and play innovation. So it's also why it takes a lot of time.
yeah, man, and that makes a lot of sense from the industry acceptance perspective. Now, again, a hypothetical question that I wanted to ask you, Alban, is if these were not the limitations that you had, that there is already an existing system, set of players out there, then what would be the ideal use case for carbon waters if you did not have to go the way where you are designing coatings that are acceptable by industry that does not disrupt their economy? What would be the ideal scenario? Because I mean it does come from academia, and pure research has a lot of applications which are, I would say, very impactful. So are there impactful applications apart from what you guys are doing that you would imagine if there were no industry based constraints or
Mm.
economies based constraints? Again, a hypothetical scenario.
So at
Yeah.
what Carbon Waters is very keen on focusing on all innovations that will have an impact on the environment and the energy.
Okay.
And one of them is battery and fuel cells. And we know that we need to be better
Yeah.
on battery performance and fuel cell performance, but also shelf life and how to manage, let's say, how to recycle everything. And we are pretty sure, because we are beginning to work on that, that graphene could be a wonderful material for battery innovation. So we have already shown using GraphUp that we can enhance the performance of energy storage, but also to stabilize the battery in the longer term, also by stabilizing all the polymers that are inside the battery. So we are using basically the same that we have done on coatings and composites, but on battery polymers, and we see very nice effects. So my answer will be to work on batteries, to work on fuel cells, and to work on energy storage. And I think it's gonna be a game changer for the next 10 years in the energy storage field.
I feel so too. I think energy storage from any source of energy is going to be very, very key. And the form factor, the energy density, and the stability or shelf life, and I would say the runoff rate, all of those things are going to play a very, very big role, crucial role. Because you need modular systems, systems that are compact, systems that can be multiplied, added together, and then you can have energy storage in place. So I mean, if that's the direction, I mean that's a very encouraging direction for the world in terms of the use of graphene innovation. Also, I mean, let me shift gears and ask you about. So, you are from life sciences background. You have a PhD. You have worked with technology transfer offices. You have also worked in collaboration with funders, European Union research institutes, so on and so forth. And that's a lot of academia that comes behind you as a pedigree. Then, how did you make a switch where you had to decide, hey, I mean, I don't want to change the existing products which are out there? How I don't want to disrupt the economies that are already in flow. I mean, was that a gradual shift? Was it tough coming from that background?
Um, Everything happened when during my PhD. So I did my PhD at Harvard Medical School in Boston. And in the lab I was working, I could see companies and researchers working together,
Ah,
hand in hand, on transferring innovation to the real economy. So when I went back to France, I had decided that I want to accelerate the transfer of academic innovation into real world because we have so many great things in our labs in France, but also, of course, anywhere around the world. And most of these innovations, they are solutions to current problems. So Carbon Waters was basically designed for that. It's to accelerate the transfer and to make what was the most challenging, but maybe the most impactful innovation in terms of materials and use it to answer current challenges in terms of energy and environment. And
yeah.
of course, so we need to manage innovation in a very different way first, but we have also new tools such as artificial intelligence
Yes.
and automatization and high um, and to accelerate also the screening of chemical compounds or chemical formulations. So we have a lot of different technologies coming from informatics, coming from electronics, and also management, and we need to use them with chemistry to accelerate this transfer of material innovation into the real world.
Yeah. And then maybe I wanted to ask you, you have been able to use these innovations in a very productive manner. So, for example, you talked about AI, LLMs coming into picture, they being able to simulate situations, scenarios for you where you can look at the viability, feasibility of certain combinations of polymers, so on and so forth. You can say, I mean, hey, I mean, this is not going to work, this is less
Mm.
stable, this is more stable, without actually having to put the actual man hours of experimentation, or at least reducing that bit, right? But this is true for, I mean, these technologies are available to a lot of people, right? I mean, throughout the world. But it's simply a curious question. I mean, research on graphene is one thing, but there are so many other problems out there, and the AI is equally applicable to others. So, what, in your opinion, is the reason, the real reason because of which the valuable research lying in academia is not as quick in accelerating to the industry side as you would imagine it to be?
I don't think it's a matter of technology or scientific approach. It's more a matter of managing people and having people around the table talking together with different languages but a unique objectives. And this is hard. This is hard because even in a classical company, when it is multicultural, it's very hard to make
Yeah.
people discussing together. So if you have like different cultures, but also different backgrounds or different sensitivity, uh, this is even harder. And I think the goal there is to make all the people from different backgrounds talking together with a leader leading in a unique objectives. And I think with that and all the technologies that are going to be developed and that are already developed, we can achieve great things.
I mean, that's a great answer because at the end of the day, it is making four people get aligned to the same objective or the same vision.
Mm,
Coming to vision, now what we have talked about carbon waters are the immediate missions. Say, for example, getting adopted as a
mm.
coating substitute or replacement for enhancing performance, so on and so forth. But in general, what is the vision here? I mean, what is it that ultimately you say that now carbon waters is successful? What will be that moment for you?
The moment we will be when we will have like we have already objectives in terms of sustainability and decreasing carbon emissions by using our products in aeronautics, automotive, wind turbines, hydrogen storage, or even batteries. And I would say that when we will be able to quantify clearly the carbon emission decrease impact of carbon waters, we will have already succeeded the first phase of development of the company.
That makes sense. That makes sense. And I think measurement is a very important criteria in such scenarios. I think the more things you measure, the more triggers you get to know that, hey, I mean, this is causing X, this is causing Y. And ultimately, this is the total impact that is coming out because of these triggers.
Yeah, and I think all the people will be even more motivated, so it will accelerate the impact that we will have on maybe all industrial sectors.
Yes.
We, carbon waters alone is not a solution; it's one of the solution,
Yeah,
but we need to push this solution at 100% to make it clear in terms of impact for carbon emissions.
that makes sense. Let me also switch the direction to the investment and the funding side of things. Now, I have seen academic research is mostly funded by the government and the ministries and the commissions that are out there. But now you are into the industrial side of things. Of course, you are still in deep tech. You are still working on things that are related to sustainability, reducing carbon footprint, and so forth, so on and so forth. But now, what is the next set of challenges in terms of funding? Is it going to be reliability on the government uh, funds available? Of course, I mean, those are good, but those are long term funds that keep fueling your research. But then you also need to scale. And when you need scale up, you need faster investments, so on and so forth. So, is there a challenge at this point of time in scaling up, Alban?
So we are in a point where carbon waters begin to generate revenues from prototype development, but also from product sales. And we don't need any more R&D investment. Of course, we need to invest in R&D to maintain our R&D, but R&D is not the primary focus of carbon waters. The primary focus of carbon waters is to produce, supply, sell our products, meaning that we have to change from an R&D model to an industrial model, and all the fundings, meaning non-diluting and diluting fundings, will be targeting these objectives. So we have already very interesting discussions to be funded by France and Europe on our industrial assets, future industrial assets. But also I'm preparing a Series A of about 5 to 6 millions. So focusing either on chemical focused ventures, but also on industrial funds and some of the institutional funds that we have in Europe and France, mostly also to invest in the capex for the
Yeah,
industrial development of carbon waters.
yeah, that makes sense.
So yeah, for the future, let's say 3 years, 2 to 3 years, we need about 10 to 12 millions. Half will be on the industrial development, 30% on the business development, and the rest on to finalize the R&D project that we have going on.
Got it. That makes sense. And one other question that was coming to my mind was related to regulations. Now, graphene is something that has not had widespread use in the industry. But do you foresee that more and more regulations will come into play with respect to the material graphene's use in the industry? Or is that not something that's applicable to this material? I mean, what's your opinion?
So Carbon Motors is based in Europe, and Europe is really keen on looking about sustainability impacts of new innovations, much more than any other
Yes.
territories. So of course, since the beginning, we are involved also in regulatory discussions. So we have representatives of Carbon Waters in several regulatory institutions in France and in Europe. And we need to separate two things: the regulatory aspects that are linked to the nanomaterials and the regulatory aspects that are linked to the final product of our customers. So of course, we focus on the first. We focus on the first, and everything on the process was designed to be ahead of future regulations that we know are going to be in place within 2 to 3 years. So we want also regulatory aspects to be a competitive advantage for carbon waters.
And that makes a lot of sense. And investing your time, effort, and intelligence in designing as well as in representing carbon waters also is a very good strategy since you're doing it from the beginning as compared to facing it as a reaction to the upcoming regulations. I mean, and that's what most people have to do, right? I
Mm.
mean, I'm seeing ESPR, PPWR coming up on recycling and compostable materials, and now people are scrambling on
Mm.
how to adhere to those regulations, and that's a tough task,
Absolutely.
right? Yeah.
Yeah,
So yeah,
absolutely.
that makes sense. Good. I think, I mean, I learned a lot about carbon waters and in general about the transition from academic research to industry applications and what's a synergistic way to do it. At the same time, I also understood that challenges keep on shifting, but they are going to be there at any stage of the industry. I mean, Earlier, it was
Absolutely.
adaption. Then it became, say, for example, proof of concept and R&D, and then became capex, scalability, so on and so forth. So it's going to be there, but I think Carbon Waters is doing good work. At least I get
Thank
the
you.
impression from your website, from talking to you. Very good talking to you, Alban. Is there a question that I'm missing that you would ideally have been asked?
I think, as you say, there are challenges in every steps of the life of a startup. And what is very stimulating is that you approach different aspects. First, R&D, industry, sales, sustainability, and also social impacts. So it's very stimulating to work in a startup company for
Absolutely.
industry.
Yeah, absolutely. And I wish you all the best.
Thank
And
you.
thank you very much for your time.
Thank you very much, Vikas. So,
Thank you.
and I wish you a very good day.